Welcome. Welcome to this morning's plenary panel. My name is Francis Sue. I'd like to thank the organizers for suggesting the topic for this panel and inviting our panelists, these distinguished guests, to be here. Today we're going to be discussing whether mathematics education effectively responds to humanities problems. And we have four wonderful panelists, Lisa Darragh, Rochelle Gutierrez, Jayasree Subramanian, and Paola Valero. You can read their biographies in the conference app on the third page of the summary sheet. I think it's fitting, as we discuss maths education, that we acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land, and we pay respect to the elders past and present who used mathematical ways of thinking in service of their communities and their land. And we strive to dignify those whose systems of knowledge have been displaced or erased. Now, we're going to be doing some interactive polls during this session, including Q&A. So if you think you might want to ask some questions, you will want to scan. You can connect to ICC Sydney Guest as the, I think, Wi-Fi access point if you have a phone. Or you can lean in on a neighbor to ask your question for you. So give you a moment to scan the code. And at the top of the screen on many of the slides, you'll be able to see how to do this manually. But I'll begin with the first question just to see who's here, the category that best describes you. We can get a sense of who's in the room. Welcome to all of you. And I'll give you 10 more seconds to make a choice, even if you don't know which category you belong in. It's kind of fun, actually, to watch, to see the responses. All right. 5, 4, 3, 2, 1. All right, I want to say a little bit about the format of this session. So we're going to devote the first 30 minutes to having opening statements. You might have read in the session outline that we're going to loosely follow the model of an Oxford debate. And you might know that in an Oxford debate, panelists may be arguing a position that doesn't necessarily represent their own viewpoint. Now, this is almost a necessity in our case, given that all of our panelists have research agendas that come from a critical perspective. And the value of seeing how our panelists step into this conversation is that it might help us all productively step into the viewpoints of those with whom we might disagree. And unlike a typical Oxford debate, we're not going to assess who wins this debate. Rather, we're offering a conversation about issues, and the panel will discuss how they think about these issues as informed by their lived experience and their professional expertise. We hope that by engaging in spirited discussion, we're going to all emerge considering ideas that we might not have otherwise considered. How do you feel about that? Good? Awesome. So our panelists will each open in a moment with 5-minute remarks, giving their best case arguments for or against the proposition. And then we're going to follow with about 45 minutes of moderated Q&A, and then close with some final thoughts. You're going to have a chance to ask questions through Mentimeter. All right, so let's just take a moment before we discuss humanities problems and their relation to maths education. What are some of humanities problems? In your app, you can submit up to 2 answers. Love to see what you come up with. Big ones here seem to be climate change, environment, war, equity, and many others. Selfishness. And then smaller ones it's hard to see is distance between people, breakdown of the family, happiness. Thank you. Okay, now your sentiments on these three statements. First statement, you just say if you agree, strongly disagree, or somewhere in the middle. Mass education effectively responds to humanity's problems. That's today's prompt. Humanity's problems should not influence how or what maths is taught. And I'm using the plural maths because this is Australia. And math education has a role in preparing students for jobs and beyond preparing students for jobs and careers. How do you feel about this? Your thoughts? One of the nice things about these sliders is you can actually see the distribution of responses. And see, almost, it looks like nobody believes that humanity's problems should, completely agrees that humanity's problems should not influence how or what math is taught. See a lot of support for education having a role beyond just jobs and careers, and it seems to be somewhere in the middle about math education effectively responding to humanity's problems. All right. Wonderful. Great. So now we are going to hear from our panelists, and we're going to start. The order will be 4 against, okay? And so it'll be Lisa, followed by Jayasree, followed by Paola, and followed by Rochelle in that order, and they'll just come up one after the other. So let's welcome our panelists.
Tēnā koutou kua huihui mai nei. E mihi ana ki ngā mana whenua ko Lisa Darragh tōku ingoa. Greetings to you all and acknowledgements to the Gadigal people of the Eora Nation, owners and custodians of this land. My name is Lisa Darragh, and it is an honour and a pleasure to be here today debating with my esteemed colleagues. So when I was offered the chance to debate this topic, I was very excited. And then I found out that I was on the affirmative team. However, I soon realised I could actually take an affirmative position. I just need to define the terms and argue from an idealist position. So I'm not going to talk about mathematics education as an institution. I'll leave that to Paola. Rather, I'm thinking about mathematics education in the sense of people being mathematically educated. And I'm thinking about a critical and ethical mathematics education here. I imagine a mathematics education that draws on Western, Eastern, and Indigenous perspectives. And while this certainly is not currently a reality in the majority of contexts, it does remain a possibility, an ideal that some may achieve. So this kind of mathematics education gives people the mindset, the skill set, and the wisdom to respond effectively to humanity's problems. Mathematics education gives people skills of logical thinking, creativity, critical thinking, collaboration, all of these necessary to solve problems. And ideally, it gives people an attitude of perseverance and a faith in their ability to take action to solve these problems. And a critical, ethical mathematics education gives us the wisdom to know when mathematics is or should be the solution. In Aotearoa, New Zealand, we talk about mātauranga, or knowledge systems. Dr. Pānea Tamaro, for example, elaborates mātauranga Māori alongside mātauranga mathematics. Ideally, mathematics education gives us an understanding of which knowledge system to use and when to use it, to know when mathematics will provide the solution we might need. So far, I've spoken of humanity's problems in only a vague sense, yet we are living in a time when there are enormous existential challenges confronting us daily. And we're also living in a time in which we have a much greater knowledge of those problems for people a little outside our own personal context. And thus, our list of humanity's problems grows ever larger, and we saw that growing ever larger in the word cloud just before. Climate crisis, poverty, water scarcity, disease, discrimination, displacement, war and violence, a post-truth political climate, the continuing effects of colonization, and the list goes on. So coming back to this issue of whether a critical, ethical mathematics education responds effectively to such problems, I think everyone here in the audience can think of many examples of how people, being mathematically educated, have used their mathematics education to address these problems. Solutions to the climate crisis we're working on, diseases such as COVID, all of these require a background in mathematics, obviously. Many people here today are working in areas such as mathematics for sustainability, or trying to encourage greater numbers of people into further mathematics, to encourage diversity in these fields. So instead, I will offer a couple of examples that are less obvious. First, mathematics education to respond to the ongoing effects of colonization. In my own context of Aotearoa, New Zealand, the development of Indigenous education, first with language nests, kohanga reo, and then later with kura, schools taught in and through the language of Māori, have been facilitated through the development of a Māori mathematics curriculum called Pāngaro, thanks in no small part to my colleague, Professor Tony Trinick. So this is an example of a language revitalisation project, redressing one negative impact of colonisation with mathematics education specifically. Second, we might consider the role of mathematics education in combating inequality or discrimination. This work has already been elaborated by Ole Skovsmos earlier this week, and many people are working in mathematics for social justice, whereby an understanding of mathematics and statistics helps empower people to read the world, then change the world. And in this space, I also want to offer the example of inclusive education, which has rehumanizing mathematics as a goal, something Rochelle herself has written on. Rehumanizing is not just an adjective, it is also a verb. Mathematics education being the vehicle by which we reject the practice of people categorized as less than human. So I'm out of time, but to conclude, I ask, if mathematics education is not a key player in responding to humanity's problems, then what is? Everyone here today already sees the value in mathematics education. That's why you're here. Thank you.
Good morning. I'm Jayasree from India, the country of M.K. Gandhi, who fought nonviolent struggles, taught nonviolence to the world. B.R. Ambedkar and E.V.R. Periyar, who fought nonviolently for social justice and annihilation of caste. Savitribai Phule and Fatima Sheikh, who worked steadfastly for the education of women, Dalits, and other most marginalized people, undeterred by opposition they faced. It is the legacy of their courage and conviction that gives me the strength to stand in front of you and make this presentation, and I feel honored to do so. I take this opportunity to thank the chair and my fellow panelists for their unstinting support all through. I want to argue that both mathematics education and the problems of humanity are deeply political, and mathematics education cannot hope to respond to them without confronting the political nature of the problems. Humanity is not a homogeneous whole. It's a conglomeration of groups of people separated by large geopolitical, socio-cultural, economic forces. It includes people who have been and are being broken physically, emotionally, economically, and in many ways by wars. People who face violence, humiliation, discrimination every day because of racism, casteism, sexism, heteronormativity, ableism, and so on. People who lost their land and ancestors and have been reduced to a minority in their own territory by colonization. People from rural locations that lack basic infrastructure, and the poor who migrate for labor, live in the slums around metropolitan cities. Tribal people who are fighting to hold on to the forests and the land where they have lived for centuries, to their values and ways of being, all of which are under attack from the logic of modern state and greedy private mining companies. The list is long. Humanity's problems do not affect everyone the same way. Poverty hides the fact that economic inequality and deprivation are integral to every form of social stratification. In India, a very large percentage of the poor people are also those at the bottom of the caste hierarchy, and they not only lack the economic, social, and cultural capital to make it in the capitalist economic order, they also face severe forms of discrimination. Natural calamities like floods, earthquake, landslides, heat wave, etc. affect the poor more severely because they are forced to live under unsafe conditions and work under extreme weather and so on. In a consumerist world dictated by the logic of market economy, huge quantities of plastic, chemical, and other toxic waste from the developed countries are traded off to developing countries, which in turn are dumped in places where the poorest of the poor live. Opportunities for equitable and quality education are robbed by massive privatization of education, which accentuates prevailing socioeconomic inequality. Mathematics education offered in a technology-enabled smart classroom with a teacher who is adequately trained to use technology for those who can pay for it is not the same as that offered in a tiny, crowded classroom where the learners sit on cold, broken floors, where the quality of the blackboard is so poor that the teacher cannot manage to work out one problem or write one equation fully, where the teachers are not trained to use technology, where the teachers have not been prepared to teach other people's children, as Lisa Delpit uses the term. Globalized technocratic capitalist structure is produced and sustained with the help of mathematics. We are living in a world that is getting more and more mathematized. Mathematics and mathematical modeling are central to all branches of science, technology, economics, and finance. Quantitative studies are highly valued in sociology, psychology, education, and so on. Mathematics is the core of what is described as the fourth industrial revolution, with significant development in artificial intelligence, machine learning, robotics, remote sensing, internet and communication technologies, DNA sequencing, gene editing, and so on. In a globalized world where production units are spread across the countries and transnational migration for labor is on the rise, mathematics figures in finding cheap labor across the world, measuring and ranking institutions, products, services at various levels. Mathematics also plays a significant role in determining tax structures and how the state allocates its resources. The banking sector arrives at interest on loan, various insurance premiums are determined, and how the prices of various commodities are determined, and so on, most of which is actually kept away from us. We are unaware of how these things happen. Humanities' problems are actively created by those who capitalize on them, and mathematics is complicit in it. Neoliberal economic policies that allow for economic exploitation, which include minimizing the cost of labor, setting abysmally low minimum wages, keeping a huge number of wage labor in informal sector, all these create poverty. Natural resource mismanagement, fossil fuel extraction and burning, increasing privatization of transportation, mining, deforestation, and so on, lead to climate crisis. Belief in endless product innovation, performance assessment, microcredit systems at the workplace, and threat of being laid off and increasing unemployment result in stress-related illness referred to as workplace epidemic. Mathematics education, as it exists today, prepares the learners more and more to contribute to the global technocentric capitalist economic structure and not to respond to humanities' problems. Thank you.
Good morning, everybody. While Lisa argued for an idealist position, I argue from an institutional position that considers mathematics education as part of organized instruction in systems of mass education. And in my position, I'll touch on some of the points that Jayasree addressed, but kind of from a completely different perspective. So from the beginning of the 20th century, if we think about these 100 years ago, mathematics as a subject of teaching and learning has had an undeniable contribution in promoting modernization, sustaining development, and securing progress to address the problems of humanity. And even though there are some problems, and I agree that there are problems and the problems of humanity are many, I think that mathematics education will continue to address these problems in the future. And this is the great hope that we have with mathematics education. But to start my argument, I invite you all to set aside our desire as educators of wishing for more and better mathematics understanding. Rather than focusing on that we have not achieved in terms of students' possible performance, levels of performance, I want you to focus on the tremendous changes that mathematics education has had over 1 century, and on how these changes indeed have responded to the many predicaments of different times. My argument builds first on the fact that mathematics has moved from being a secondary subject taught to some people, to few, to become a subject which is a main subject of schooling. So no matter where in the world we are now, children receive mathematical instruction, and for many hours. This was not the case 100 years ago. According to UNESCO's Global Education Monitoring Report 2024, right now, 87% of children complete primary education, compared to a rough estimate of around 20% of the world population that completed some form of primary education in the 1900s. Also, the mathematics curriculum has expanded in significant ways, from including basic arithmetic and practical skills to now being a comprehensive organization of aims, contents, pedagogical strategies, supporting technologies, and encompassing assessment and evaluation. So with this expansion, mathematical competence and its power has become central for all human beings. Furthermore, there are 2 points that I want to mention, which are central values that the school curriculum has promoted in modern societies aspiring to improve human life. One is the formation of modern mathematical subjectivation and its quantitative mentality, and another one is the strengthening of human capital. So those are my 2 points, the two that way. So the first one, in different times, mathematics education has provided citizens with needed qualifications for life and work. It has secured enough people to produce new mathematical knowledge and apply it in science and technology, as Jayasree has already told us. The curriculum has been reformed to adjust to changing societal needs and aspirations, to improve the capacity of citizens, the qualifications of the workforce, and also the development of new forms of knowledge that support our dear modern life. Most importantly, mathematics education has contributed to form a form of modern subjectivity, which is that sense of us humans that can see ourselves in relation to important ideas such as rationality, universality, objectivity, generalization, and abstraction, and these becoming important epistemic virtues. Such form of subjectivity establishes and sustains a quantitative mentality, which is this idea that mathematics, through mathematics, we can indeed manage and control the world, both at a personal and a societal level. And this is a very important shift that started happening before the 19th century, and that mathematics education has helped sustaining and advancing. As an example of all these many technologies that Jayasree mentioned, think that for mathematics education to work, or for a society to work, we need producers of technology, those who can do the production of technologies, but we also need lots of people who can use these technologies. And these two people, producers and users, independently of how much they have benefit from the curriculum, are necessary. Without any of these two and all the others in between, we wouldn't be able to actually have the world that we have now. That is my second point. And my third point has to do with the strengthening of human capital. Now, modernization is about transforming and optimizing natural and human resources to improve material life conditions. Since the 1950s, economists have recognized that human capital is central in growth and advancement, and both individuals and societies benefit from the investments in people, that is, in people's health, well-being, and in particular people's education and qualifications. And of course, probably that is not equally distributed, but at large, if you think about the conditions that we have now compared to those that there were around the world in 100 years, there is a great difference in how our lives are now. So besides the many positive characteristics that mathematics gives to people, like what Lisa had already mentioned, the measurement of mathematical competence allows to estimate the current and potential human capital of different individuals, groups, and nations. Thus, we have very powerful tools to advise governments. Some might need to increase and improve and do serious investments in mathematics and science in STEM areas, but some other ones might need to twitch and adjust their curriculum to be able to respond to the challenges of nowadays. And indeed, UNESCO or OECD are doing that, for example, with the recent initiatives on and aligning mathematics curricula to global sustainability goals. So this is an example that at any time, actually, we will do these changes that are necessary. And having said that, one can always wish for improvement. That's why we're here. However, the possibilities of changing and adapting the mathematics curriculum, as we have already learned how to do, are the solid basis that we have now to keep on facing the very many challenges that appear there in the cloud in the future. Thank you.
Cuirava, Nije Coriwe Rochelle Gutierrez, Ranara Niwara, Ruben Gutierrez, Ave Josefa Perez, Niwara, Aguascalientes, Ave Chihuahua, Mexico. I greeted you in my ancestral language of Raramuri, and I pay my respects to the Gadigal peoples who, for thousands of years, have nurtured the spirits and the lands and the waters that we are gathering upon today. I want to start with the first point, talking about the problems that we are facing, and that one of those problems is well-being and our connection to each other and to the natural world. The root of many of the problems that Jayasree and others have talked about actually come from the not being able to care for ourselves or for others because we're alienated. We've been sold a colonizing script of scarcity and precarity when our more than human relatives model for us on an everyday basis that we live in a world of abundance, that there's more than enough if we live in right relations. And when I talk about well-being, I'm not talking about an individualistic or kind of a biological perspective. I'm talking about well-being extending to others and to lands and waters. My second point is that the mathematics education, and I say mathematics education, it's the institution. So I am talking about the institution, not an idealized form, not a form that we hope for in the future. That the current version of mathematics disciplines our minds and bodies. And by doing that, it creates compliant citizens. How does it do that? One of the ways is through algorithms. Algorithms teach people to follow arbitrary rules. I say arbitrary because in most mathematics classrooms, students are never really taught, where do these rules come from? Who made these rules? So for 12 years of sitting in compulsory mathematics spaces, where you're not taught to break those rules or to question those rules, that sets you up for being the kind of person who has to follow arbitrary rules that others in the government, in other countries, make for you. A second way that it does this is through an over-reliance on binary logics. Binary logics teach people to see the world in parts and as truths, as odd or even, as right or wrong. And this justifies some people those of lower caste, those who are black, who are indigenous, disabled, Muslim. We can go down the list, and if we extend to our more than human relatives, forests and streams and skies and ants and bees, as deviant from the ideal human, and therefore non-human or disposable. The third way that it does this is through a Western rationality. So the abstracted logic is the highest level of thought, and it's a form of dispossession for many of us who are indigenous, who don't separate body and mind and spirit. When we're taught in math classrooms that relying on your fingers to count is a primitive way of doing mathematics, we're being taught to ignore our bodies as resources. We're being taught to ignore things like intuition when we're asked to show that we know something mathematically by only talking about the general case, by doing the formal proof, and not thinking about things that maybe we carry within us that we know. And there's so many other concepts that I can go through, precision and rigor, and we can name them all. And then when we partner that with mathematics that's seen as a proxy for intelligence in society, right? Mathematics has this unearned privilege in society. We say if you're mathematical, you're smart. But we could say if you relate well to people, you're smart. Or if you know how to think holistically, you're smart. Or so many other things. But when we take this abstracted, when we take this abstracted logic as this sign of intelligence, then we get to the idea that smart people are people who ignore the realities that are around them, including those who are suffering in your presence. And then the winners of the system, the mathematicians, are ingrained with this sense of elitism, right? So this is the natural order of the world. There are some people who are good at math and some who are not. We are the creators. And so those who can't do pure maths do applied maths. And we can question that very word of pure mathematics. There's nothing that's actually pure about it. It's just abstract. The last part of my presentation is about humanity's problems, and that we need to also interrogate what we count as mathematics. So it's not just that we need to apply mathematics in more ethical ways. Mathematics is presented as pure, objective, universal, yet it's a set of aesthetic choices that have been made over time. The current version that we're using is actually quite young. It's only 200 years old. It's a modern mathematics of the global north. It's one of many mathematics that we could embrace. We could have an ecology of mathematics. Mathematics is also axiomatic, and many people don't think about the fact that mathematics as a tool doesn't actually help us learn new things. It actually only helps us prove that which we already believe to be true. I just think about this moment that we're all in. We're in a great awakening. Many people are in a great awakening, but we have all been touched by the grief of diaspora. Everybody in this room has either been forcefully removed from their homelands, have had other people occupying their homelands, are occupying other people's homelands. We are all entangled in this. We have a longing for a sacred longing for place. And indigenous cosmologies offer us alternative ways of being and living in the world, surviving for millennia through mutual and reciprocal connections to each other. There's a saying in Raramuri, which is Tamoje Iwigara, which means all living beings, physical and spiritual, share the same breath. So this institutionalized mathematics that got us to this moment of climate crisis, of fascism, of all the things that we kind of saw on that screen, is not the mathematics that's going to get us out. And I'm going to repeat that. The mathematics that got us to this moment is not the mathematics that's going to get us out. Critical mathematics highlights that the mathematical practices that we participate in implicate us, but they also have the ability to heal us. It's not that we need to create something altogether new. Otherwise, forms of mathematics are regularly being practiced by indigenous people since time immemorial. We need a mathematics that embraces not just critique or social justice, but spiritual issues that reflect upon our collective, desire-based practices and indigenous futurity, and that can support us to be good Anyawari, or good ancestors. Mate tereba. Gracias. Thank you.
All right. Now that we've heard from our panelists, we want to give you a few minutes to chat with your neighbor about anything that these opening statements have prompted for you, any questions that it raised for you. And I want to point out that in the app, you can ask questions using the Q&A button at the bottom. If you keep your questions brief, it'll be easier for other people to upvote it if they like it, okay? And so you can also look at the questions that have been asked and vote on the ones that you'd like to see the panelists answer, okay? So take 3 minutes to turn to a neighbor and chat. All right, welcome back. So we're going to have a time of moderated Q&A, and if the AV people could put the slide up, that'd be great, just so that people can see. So you can once again ask questions in the with the QR code if you have questions. But I'm going to start just with picking up on a couple of things that our panelists have described, talked about. Paola talked about the quantitative mentality as being a benefit of mathematics education, and we can all think of ways that math is used to solve problems like model COVID and things like that. And so there is some value to the quantitative mentality. On the other hand, Rochelle picked up on this idea of rationality, abstraction, in some ways maybe going too far, and us forgetting the parts of us that are very human and very important. And so I guess I want us to have maybe a little conversation about this. There's a tension here that I'm feeling, and I'd like us to discuss that tension. When is math education going too far? So in Rochelle, in your presentation, what's good about about rationality, if there's something to be good to be said about that? And Paola, when does it go too far? Maybe not just for you, but all the panelists can weigh in here. Yeah.
I mean, I think
You all have
I think that rationality is an important way of learning. It's an important way of viewing the world, but I think what happens is that we have this over-reliance on rationality as the highest level of thinking, right? We don't honor other ways. We don't say this is one tool. We kind of say this is the tool. This is the superior tool. And so when we do our modeling, we forget about the context, and we try to reason and abstract and come up with things in this other space. And then we try to come back to the original space maybe. But in all of those practices that are happening, we're ignoring what's happening. So the actuary is trained to not think about what they're actually doing when they're modeling to decide for an insurance company who gets health benefits, who has access to car insurance, or any of these other kinds of things. The mathematical practices that they're engaged in requires them to kind of ignore all of those realities and not think about the consequences.
But at the same time, I always come back to a quote or some words of Villani, who says that exactly one of the characteristics of mathematics is having this power of simplifying a problem to make it operationable. And actually, yeah, of course, the world is complex, but we need tools to be able to operate and to act in that complexity. And without that I think that he is very right, that this is one of the central characteristics of mathematics. And we should be able to do that exactly in these problems as well, the problems that we have. So I think that the tension is exactly what is central and characteristic of mathematics. Well, we can leave the contextualization and other kinds of the ethical thinking about mathematics to groups of people who apply this kind of rationality and thinking. But without that, we wouldn't have been able to construct the world that we have. So how do we deal with these?
Can you hear me? Is it on? Okay. I mean, I mean, I agree with Paola that yes, true, you do want to be able to use mathematics, but then when you're simplifying a complex problem, there are many ways to simplify. There are many ways to model. It is actually the kind of choices that you make in the models that you think would work that actually politics comes in, and that who gets included and who gets excluded. Whose situation is not taken into consideration, who are the disposable people, all that figures, and also they're hidden from us, because we can actually then put everything in terms of X and Y and Z, and then people disappear from us, and then it's only objective solutions, which may have consequences, very drastic consequences for human life.
Thank you. So, go ahead.
I would just like to add that since we are in this reality where mathematics is used in these ways, it's the responsibility of mathematics education to understand the way that mathematics is being used. So we see this done quite well in statistics education, where we learn to question where the data came from and question the sample and question the assumptions. And I think that's a responsibility of an ideal mathematics education.
I'm going to pick a question here from the Q&A, which was skills, mindsets, and wisdom can be developed outside of mathematics. What's the unique contribution of maths? And maybe I'm asking it more of this side. You don't have to, it doesn't have to be just you, but yes, what's the unique contribution of maths? I mean, go ahead.
I mean, I think we don't need to think about mathematics as being the unique subject. I think I agree with what Rochelle, I'm moving out of character, sorry, Francis. But I agree with what Rochelle was saying. I mean, mathematics has this elite status, and I think maybe we can break down that elitism a little bit. It doesn't have to be unique. It's part of our education.
So I just need to come back and say that I don't think that we can use the master's tools to dismantle the master's house. Audre Lorde.
Well, but if they were not master tools, you wouldn't have a master house in the first place.
I just don't think that we can use mathematics as our way out. I don't think the current forms that we have of mathematics are the ones that are going to get us out of this situation that we're in. And I'm not saying that we need to have completely new mathematics, but I think that we really need to expand what we count as mathematics.
There was a question that came in from the Q&As. What mathematics will get us out of this moment?
What mathematics?
What mathematics will get us out of this moment? If it's not the math that got us in, what's the math that will get us out?
I'd like to say that the mathematics that we have now is becoming more and more algorithmic, less and less transparent. I think that we must have a mathematics that is less algorithmic, more transparent, number one. Number two, I also think that our understanding of what counts as mathematics education should expand to include probably also history of mathematics, as learning about history of mathematics, learning to understand the use of mathematics in the larger society, and also the kind of work that Eric Goodson talks about, like how to use mathematics to understand the lives that we are living, mathematics for citizenship. I think these are very important, that I understand how the society, how resources are allocated. Why am I poor, and why am I living in a place where I do not have a proper road? I think how the state allocates funds. These are things that I think I need to understand much more before I solve Fermat's last theorem.
Could you all comment on the role of joy and wonder in math learning? So, I mean, one of the things that I often think about is the joy that kids experience when they solve a difficult problem, and the wonder that they experience when they see something that's beautiful. What role do you see that playing in helping students be excited about mathematics and using mathematics to better their communities?
Sure. I mean, I like to think about the importance of problem solving within mathematics education, but I think problem solving doesn't capture everything that we think about when we think about problem solving. So sometimes we want to just explore and investigate a situation mathematically, and through doing so experience the joy and wonder. When I used to work in Chile in the ARPA team, there was this lovely little maths problem that we would begin with, just a 4x4 square, where you had to count the squares, and people would, and children would be just amazed at how the solution was, in the abstract, a sum of squares, and it was just completely joyful. And then on the other hand, we need to experience sometimes the solving of gritty, realistic, contextual, relevant to the lives of the children kind of problems, and using mathematics to solve those. And they're very different, but I think both ideally would be part of a mathematics education.
Yeah, I mean, there's lots of ways that people can get excited about mathematics, and many different ways to experience that joy. I was thinking, I guess, in terms of, there are lots of reasons people think about learning mathematics, and I think we all agree there should be more to math than just the math itself in terms of getting good jobs and careers. We often hear this argument, math for citizenship, which is valuable and important, understanding the world. And so I was just trying to pick up on maybe a third aspect of that.
I'll pick up on that. When I think about the kind of mathematics that can move us forward, I think about the idea of mathematics as really just pattern structures and logics. So how do we, if we think about that concept of mathematics as just pattern structures and logics, how do the patterns and structures and logics that we as humans live, that our more than human relatives live, that we are all actually entangled, that mathematics is this connection for us, these mathematical practices of pattern, structure, and logic. We've actually learned pattern and structure and logic from our more than human relatives. They are our first teachers. And once we start to recognize and are able to reciprocate and show gratitude for those patterns, we start to get into that space of saying not only, and we can, I think about how we can recognize other people's ways of doing patterns, structures, and logic. So even, like, if I reduce this down to like a classroom level, I can think about in a classroom space, how is a student supported to do a mathematical problem with somebody else and to stop and affirm, like, oh, you do this thing in the same way that I do this thing, but you do it kind of different. We're mathematical kin. Like, there's a way in which you think about pattern, structure, and logic, and that you perform it is kind of like how I do it. We're actually all connected. And when I think about a world in the future, I think mathematics isn't that thing that you say to somebody that you do and they go, oh, you must be smart, or I never got it, or whatever. And they think, oh yeah, mathematics, that's the thing that we all do. My 3-year-old does it, the plants do it, I do it. Like, we're actually all entangled in this pattern, structure, and logic, and that it's that connection that it can provide for us.
I think of this example. When my son, who's about 4 right now, first started to talk. He one day asked us to turn on the big phone, and we were like, "What's the big phone?" And he led us over to the TV, right? And so here, I think it's a perfect illustration of the fact that as human beings, we naturally are led to abstract, right? To say these two things that look different are actually the same. And so part of our job, it seems, is to cultivate that. And so maybe a question, do you want to pick up on that?
Yeah, I think that what you're saying is very nice, but I think we have to take that with a pinch of salt, because any of the persons who is here and has had success in mathematics, I think that you have experienced that, yes, there is a beauty and joy with the 4 squares or whatever. That was your example, Lisa, sorry, but I don't remember. But also, a lot of achieving really mathematical understanding demands a lot of effort, resilience, and really concentration on things that are difficult. So probably we might be talking about kind of forms of very simple mathematics, but mathematical joy at a higher level also comes with lots of concentration, effort, and also almost suffering, right? It is not easy to solve a difficult mathematical problem. That is the one thing. And the other thing is that the types of mathematics that scientists do now, that recently I had the opportunity of seeing or talking to a person who does modeling of trees and woods for addressing issues of climate change. This woman, who's first a biologist, ended up being a very skilled mathematical modeler trying to do research on the capacity of woods to absorb CO2. What she discovered through her very really astonishing ability to connect mathematical models to trees, to the bark of the trees, to the leaves, and all these things, is exactly a type of science that is a science for the future. So what I'm saying is that we might have a very romanticized idea of some forms of mathematics, but to reach to the mathematics that might move us forward, there has to be people who experience some of this hardship that brings us further in mathematical understanding for solving really complex real problems.
Could I add something? Could I add something? Well, I mean, as a student of mathematics, I have enjoyed, I have experienced joy and the beauty of mathematics. I'm a student of mathematics. But at the same time, as a teacher of mathematics, I also encounter students who are terrified of mathematics. I need to also take into consideration the fact that mathematics is a gatekeeper, which actually does not simply keep out those who are not good at mathematics. It actually keeps out a whole lot of people from the marginalized sections. The people who actually like to be part of mathematics, who seek the joy of mathematics, for whom it is denied because mathematics education has not engaged with the question of exclusion. So for example, I mean, much is written about how mathematics is a male domain, and much is being talked about now today as mathematics as, in the Indian context, if I speak, it is basically the Brahmin men who actually do a lot of mathematics. I mean, university departments are full of men, and most of them are from dominant castes. We need to deal with that. I mean, why is the joy of mathematics, the beauty of mathematics, not made available for those from the margins of the society? That question is not addressed.
I also think that we're stuck in this binary logic. I'm not saying, I hear what you're saying, Paola, that it sounds like it's a romanticized version, but I'm not saying that we get rid of everything that we've done in the past in mathematics. I'm saying I think we need to be open to expanding it so that we can have things that are about rational thinking, but not that alone or not that centralized, so that we also are able to see the ways that we are interconnected through pattern, structure, and logic.
Go ahead.
As well as expanding what mathematics is, we also need to expand who is allowed in. So just picking up on the gatekeeping role, I would also suggest that the gate used to let fewer people through than it does now. So we are opening the gate a little, we just need to open the gate wider so that when people experience that challenge and that difficulty and the struggle, it doesn't shut them out altogether. Because I think only with a diversity of people with mathematical skills will we really address the problems of society.
Maybe there is something in what Paola just said earlier about the wrestling with a really difficult problem. In some ways, yes, that's part of people do it in other fields, but it's cultivated in some strong ways in mathematics to actually sit with a problem for a while, if it's taught well, learn how to sit with the struggle. And so I want to pick up a question that is the highest rated question so far in the chat, which is, what about the view that mathematics is a neutral tool, and whether it responds to the problems of humanity depends on how we choose to use it?
Well, I argued that it is not neutral. I think that mathematics is, can you hear me? Yeah. It is not neutral at all. I mean, we make choices about what mathematics to teach in school. we really decide that it has to be one that in which actually we privatize the competence. I mean, it is individual competence that is prioritized over competence that could belong to a set of people. I mean, I do not need to individually excel in mathematics. I need to be able to participate in mathematics, be around with people. I really think that we need not actually put one against, make it competitive. That's quite problematic, and I think, and not all of mathematics. For example, if you have mathematics for citizenship, I really do not know if that's going to become part of the questions that one would ask in an Olympiad examination. Which is actually tuned to, so that's a choice that one makes, whether do you want a kind of mathematics that will actually get you to excel in Olympiad examination, or the kind of mathematics that you want to get people to be able to challenge and to be able to participate in a democratic, as democratic citizens.
I'm guessing the questioner is asking potentially the view that there's this thing called math, and then how we choose to use it is how we choose to teach it, what choices are made in the classroom about both content and practices. Is there, yeah.
Yeah, and this was the point that I made at one point in the presentation when I said it's not just about we need more ethical uses of mathematics. I actually think we need to question what counts as mathematics, because it's the underlying logics, it's the underlying practices that we are all being institutionalized into, and not thinking about how those serve as a form of potentially numbing us, disconnecting us from other ways of knowing and being in this world. So it's not just that we need to make more ethical decisions with the mathematics and keep the tool as the same tool. I feel like we need to actually be, and again, I'm not saying we need to completely replace what we have, but I do think that we need to expand and think about whether the tool that got us to this moment is the tool that's going to get us out if we're just more ethically minded.
So let's turn to maybe a practical version of the question. So there's a question here that is basically asking, what can maths educators do? And I guess I want to just probe a little bit. Like, when we think about math solving humanities problems, often we turn to things that are in the domain of college-level mathematics, like differential equations to model climate change and things like that. But let's think a little bit about the K through 12 domain. Like, what, in terms of content and practice, can you suggest educators think about? Like, is there one implementable idea that they might take away from our conversation today that you would say, okay, this is one way maths education should change if we want to better address humanities problems?
This is what I was trying to get at when I was talking about a critical and ethical mathematics education. You can start talking about ethics of mathematics from a very early age, and you can always encourage a critical view of the mathematics that you're teaching in schools. You can, when you choose the problems, and you can choose, I think someone the other day talked about ratios with lemonade, or you can choose to use real ratios that do harm in society, and use those as examples in your classroom, and that immediately gets into critical and ethical mathematics education.
I think one of the challenges, though, it feels, is as a teacher, is like, I wasn't trained for this. I think I was just trained to teach the maths, and now I'm involved in, I need to think about ethics. Like, I wasn't trained for that. How do you help somebody think through that?
You can make it a course at university.
And not only ethics, right? Teachers right now in schools have to think about ethics, about how to make the children behave well, and how they're going to be dressing or not, and all kinds of the tons of tasks that we're giving teachers, and mathematics teachers are increasing. I think of just an example, right, to come to a point on the discussion of ethics and mathematics education. I have this microphone in my hand. I can use it to speak. I could use it to come and bump Rochelle on the head because I didn't like what she said, right? I'm not going to do it. But who's to held accountable for my use of the microphone? Is it the person who made the microphone? Is it me? Or is it Rochelle for having said something that was annoying in the first place? Right? So this is the thing that I think this is a debate in mathematics education when we come to the ethics of mathematics. And it is the debate, how far are we going to go in holding people accountable for the knowledge that's being produced? Is it a mathematician always accountable for producing and proving a theorem? Or is it the very many people who are kind of people sometimes we don't understand what they do? Is it politicians to be held accountable for organizing a curriculum in a particular way? Is it the engineers who wanted to make more money and then did bad calculations and then the bridge fell down and killed some people? Or is it the mathematicians who in the first place created the mathematics to be able to build a bridge? So here I think we have to be careful of what is it that we're talking about. Mm-hmm. And this applies also then when we're having the conversation about ethics in the mathematics teaching and in mathematics classrooms. Mm-hmm. We cannot put all kinds of responsibilities on people.
I want to point to an article that was written by a research mathematician, Federico Ardila, whose research is on a very abstract form of mathematics that relates to robot motion planning. And what I liked about this research paper is that he actually spent a part of the research paper thinking about the ethical implications of how this math, while still very far from any kind of practical uses, might be used in the future, and encouraging a reflection on that and as a model for all, I think, all of us who are doing research in mathematics.
Can I come back to the classroom?
Yeah.
So when I think about the mathematical practices, because I think there is the ethics of, again, the ethics of the ways that we use the tools, that's the current tool. But if we think about how do we question mathematics as a practice, we think about what are the actual practices that we have students do. And I think on a very basic level of when are students ever creators of mathematics? Because if I am taught to be a consumer of this thing, then mathematics is being done to me, right? But if I'm actually creating forms of mathematics, then I can see that there might be other ways of doing mathematics. So on a very elementary level, like you learn 4 operations in school, you learn addition, subtraction, multiplication, and division. What would it look like if we invited students to come up with a 5th operation? What would that operation do? What would it look like? Where would it be internally consistent? If we think of statistics, we can say we have mean, median, and mode. What other form might a community want to know in terms of data? What would serve its purpose? Why would it be similar or different? All these ways of like asking students to kind of come up with other practices in mathematics is actually what mathematicians do. And then when we can point that to students and say, you know, we are currently doing Euclidean geometry, but when we ask people to ask questions, to think about what could be something that would be different, that's how we got non-Euclidean geometries. That's how we got complex numbers. That's how we got all these other things. And so I think it's also in the practices that we're regularly doing in classrooms. It's not just the ethics of the mathematical content that we're applying.
I want to say that, I mean, ethics, teachers' ethical practices are not independent. I mean, like, teachers cannot really function independently. Teachers are placed within a structure, within an institution. Mathematics as an institution, actually, in India, at least, teachers do not have the autonomy to do what they want to do. Without teacher autonomy, the question of ethics, that teacher using ethical practices cannot really be realized. It can only be done in a very minimal way. And unless mathematics as an institution engages with the questions that we are talking about here, I really do not see teachers alone being able to actually bring in ethical practices in the classroom. They are, I mean, as a practicing teacher, as a teacher in the classroom, I always find myself challenged between what I think is the right thing to do and what I think that I'm expected to do. And I think that is the challenge that we have.
I want to pick up on your point about practices, I'm often thinking that in my classroom, often, you know, in maths, one of the things we like to do in a maths classroom is help people see that they can solve a problem by looking at it from many points of view, right? There are many different approaches to solving a problem. And I think about that in this time that we live in, that's great political polarization, that I started thinking about this recently, that part of what I'm also doing in the classroom is I want my students to see that other people had different ideas than they did, and I want them to begin to talk to begin valuing listening for the perspectives of others. And so I'm wondering, I'm throwing this out as an example of, I guess, a question, which is, are there things that we can do in our practices, in the classroom, that can contribute to helping solve the problem of polarization in this day and age?
I'd just like to follow on from that. I had the privilege of working in a classroom with a teacher, a wonderful teacher of 7-year-olds. And it was in the time that just after all the COVID lockdown, so the children had done 2 years of very broken schooling, a lot of it at home, a lot of it on devices, a lot of it individual. And I was privileged enough to watch her teaching the children how to listen to the other points of view. And she had to do it explicitly. She had to really talk about how you disagree with the other children, how you say, I have a different way of solving the problem, or I did it in a similar way, but here's what I did differently. And she modeled all of those talk moves with the children, and it was very enriching. And one of the biggest outcomes of it is that the mathematics classroom turned from a place where the teacher had the only answers to a place where all the children could learn from each other.
Can I pick up another question from the audience? What can we do to stop the technological and poverty gap, as these situations seem to be getting worse? As a teacher, I see this every day, and the widening is accelerating and only get worse. And I want to focus us here on, in particular, mathematics education.
Well, I think that if we go back to the institutional perspective of mathematics education, if the problem of technology gap can be seen in different ways, but I imagine, or I interpret this question in terms of people who do not have access to these technologies that are lagging more and more behind, and that is not only elder people, but children here, children in conditions of poverty. And for me, that is one of the very key issues in an approach of human capital. And I think it is very lucky that we have exactly sustained evidence of the type that we have with large-scale international comparative studies that recently have taken the issue of technology and the use of technology and advancement of technological competence to exactly try and do a connection between international agencies, national policies, to really address this problem. If we hadn't had all those that information, and if we didn't have ways of very concretely adjusting the mathematics curriculum, this problem would be even more difficult to solve. An example, probably in very many countries around the world in the last 10 years, there has been a trend to include, for example, algorithmic competence programming as an integrated part of mathematics education. This was the very clear case of Sweden, and actually I think that the effort that we can do at a systemic policy level is a way of addressing this problem. And I think we cannot underestimate that power of exactly the large system of mathematics education. It's not only a problem of practice. A teacher alone cannot solve this. Policy can solve it.
I'm going to highlight this question that came in, which relates to something we talked about a while ago. Should we be viewing mass education in isolation or as part of a larger interdisciplinary picture where we provide the tools to students to make changes in their immediate world.
I think so. We should. Yeah, I think we should be thinking of mathematics education as something, as part of the larger interdisciplinary picture that we provide. I think
Put it closer to your
certainly I
mouth.
think that is, yeah,
Mike.
certainly we should change mathematics, the whole pursuit of mathematics as an ideal, nice pursuit that individuals sit in their little cubicles and devote themselves to it. You can do mathematics and keep the problems of the world away. It kind of acts like something that, kind of helps you get over the problems of the world. Instead of that, actually, we must make mathematics into that which addresses not only the problems that interdisciplinary in nature, it should be definitely, but also that it should be reoriented to address inequality. And I think that if we want to change the way the world is today, I think we need to change the way mathematics is.
Okay, so I am now going to have us think a little bit about some of the things we've talked about, and let me just suggest the following. So there are several questions. We won't get to all of them. Okay, maybe quick weigh-in. This is one about teacher shortage. I'm not sure what the direction of the question is, but do you want to comment anything about teacher shortages globally? I'm not sure this directly relates to our discussion, but it was a popular question. What do you think? They were noting that there are mostly math education researchers here and not as many teachers, which could be for a number of factors, but there are teacher shortages globally, and is anything we're saying related to how we can attract more teachers into the profession?
Yeah, I think I might come in with this one. So I was a teacher in high school, and I've, for the last 30 years, been preparing teachers at my institution, and I'm so fortunate to be able to work with teachers on a regular basis. And I think about the research that I do and the ideas that I come up with not being disconnected from that space. But a lot of the work that I do with teachers is around creative insubordination. It's around helping them understand the histories of what has come before them in terms of even like teacher education. Like in the United States, you didn't used to be paying $300 to Pearson and sending a 15-minute video for them to decide whether you were a teacher. It was something that was decided upon by bodies of education professors. And so thinking about, as many people, at least I'll speak from the United States, many people don't see teaching as a profession to go into because so few people have autonomy or are able to express any professional judgment. And so what does that mean to enter a profession where you don't actually get to use any professional judgment? You're just expected to follow what the district is saying because there's so much pressure to create test scores. So I think part of what we've been talking about is this kind of critical perspective in mathematics. I think the history of mathematics is part of that. I think helping teachers see that there are many mathematics that are practiced in the world. I think these are the kinds of things, and then supporting them to be able to navigate the politics of the systems that they're going to participate in is going to better prepare them and maybe help them see that they have a role to play in the space that's not just reproducing what we typically do in mathematics education.
Great, thank you. All right, so in a moment, I'm going to ask our panelists, we're going to wrap up by giving our panelists 2 minutes, 1 or 2 minutes, for any final thoughts, things that you want to leave our audience with. And I want you all to recognize how the challenge of just being on stage and having this kind of public conversation and also taking stronger viewpoints in various directions or different viewpoints than you might otherwise in person. So they're going to think about this, but you are all going to participate in your closing thoughts on these 3 agree or disagree statements. And the statements are: mathematics education has great potential to address humanities problems. Math education can improve through critical examination of its contents and practices, and the discussion helped me consider new perspectives.
And we
appreciate all the hearts. When those come up, I just feel
The hearts are appreciated. Parting thoughts in any order.
Paola accused me of switching sides during our talk, but I haven't really. Because ultimately, while I agree that mathematics is, as Jayasree said, complicit in many of humanity's problems, and I do agree with many of the things that both Jayasree and Rochelle said, I think when mathematics is part of the problem, then mathematics education must be part of the solution. And so the way we do things within mathematics education, from our role as educators all the way through down to the early childhood teacher, if you like, not that that's down, I should have said it the other way around, it is our responsibility to redress some of the power that is worked through mathematics.
Microphone too.
Okay. My final statements are that, I, as a person who's teaching mathematics, I really look forward to a time when school mathematics can actually be, connect to the lives of the people, in the sense that it actually allows everybody different ways in which they can bring their mathematical knowledge that exists amongst them into the classroom. So what we do in the classroom should connect with what they actually do in their lives. Mathematics education, I really feel, should cease being individual achievement and be a community, a collective gain. I think mathematics education should be reoriented to focus on gains that communities and sets of groups of people make rather than individuals make. And it should really bring in a lot of history so that we see, it should actually include history so that we actually understand that mathematical knowledge is produced in context, and it has its own, the aims of mathematics. Not only the aims of mathematics, but the very creation of mathematics itself actually has certain kind of perspective that decides what kind of mathematics that we will actually create, and that we need to acknowledge there are multiple forms of mathematics in the world, and each actually comes up in a certain kind of a context, and teaching history and the context of mathematics is actually extremely important, and that would actually help us also move towards creating mathematics that will contribute for democratic citizenship.
Well, I think that definitely the challenges that we have ahead are not simple. It seems everything is getting more and more complex, or probably the world has always been complex, just that since we are living this world now, it is complex for us. We're living in this world. I think that if mathematics and the ways of thinking mathematically and the tools that we have and the ways in which they have been practiced had not have such a significant cultural impact across very different nations and languages and religions and so, we wouldn't be here. Systematically, some of the largest resources are being invested in precisely us, so that we can keep on moving up in a powerful way the world forwards. So whether we enlarge that type of cultural project, well, we'll see. And probably that's the challenge that we have to take. And having said that, yes, I was saying to Lisa that she changed team, but whoever knows my work, if critical research in mathematics education should help to something, it should be to actually know which are the viewpoints of of which are problematic in the work that we're doing. And that was somehow from my research, I was taking these points because these are the points that I have examined. Just in case some of you might be guessing, like, what happened to Paola? Did she get something crazy? Did she fall down and woke up as a different person this morning? No, that is, I try to keep my role in this debate.
For me, I think I come back to the original statement that we had about whether mathematics education is effectively supporting us to solve the problems of humanity. And I think that I had continued to think in my head about we need to come back to those terms. What counts as a problem? What counts as education? What counts as mathematics? Again, I just underscore that mathematics education as an institution today continues to carry out the desires of the state. It does that by disciplining our minds, our bodies, and spirits through things like algorithms, binary logics, abstraction, precision, rigor, as superior forms of intelligence. And in doing that, it trains us to be alienated from ourselves, creating false dichotomies like mind and body, us, them. And it alienates us from others who those binaries make it seem as if we can separate ourselves from our more than human relatives or from all our relations. And that makes it extremely difficult for people to actually use mathematical practices to care for themselves or for others, or to be in good relations with lands and waters or ancestors past, present, and future. You were saying, Paola, that like we've gotten here, we've used these tools, but I don't know if we're going to be here in 7 generations. I think that we need to also move beyond damage-centered practices. I think as a research institution, we tend to focus on deconstructing the problems and needing to justify what is wrong and what we don't want before we can move to desire-based practices. But I feel a sense of urgency right now. I feel like we need to be building the futures that we want to belong to and the mathematical practices that can support us to heal and to be at one with the cosmos. We need a mathematics that can embrace not just critique or not just social justice, but also supports us to think about spirituality that's ethically based. And we need an ecology of mathematics and mathematical practices that rely upon collectivity, longings, and indigenous futurity that can support us to become good Anyawari, or good ancestors.
Can you just thank our panelists for their good cheer and preparation?
And thank you to Francis for being an awesome moderator.
I just want to reemphasize that in preparing for this panel, our goal was to be a conversation starter, not a conversation finisher. And so as you move out into the break, which is coming up, we hope that you will have some good conversations and some good camaraderie as you meet others and chat with others. Thank you so much for being here.